All right, welcome to the Exponents and Logarithms portion of your practice quiz. Let's go through this thing. Question one. Basically, they're saying all of this information up here can be written to look like this. And if you did that, what would A be? Okay, and it says right here that A is an integer. Okay, so here we go. Step one, I do think a lot of you guys benefit from separating this out just so you can see exactly what's happening here. Same with this, actually. So if you like to do this, you could rewrite this as saying 2 multiplied by x to the third power raised to the negative fifth plus 2 multiplied by x raised to the negative 3. Okay. All right, next step, I am just going to go ahead and distribute down this exponent of negative 5. And what I get would be 2 raised to the negative fifth times x to the negative 15, right? Because the negative 5 goes there, and 5 times 3 is negative 15. Okay, plus 2 times x to the negative third. And I just rewrote right there so I can kind of keep it all consistent. Next step, we just think about the reciprocal rule for exponents, and this can be rewritten like that: 1 over 2 to the fifth, 2 raised to the fifth, multiplied by 1 over x raised to the 15th, added to 2 multiplied by 1 over x raised to the third. And at this point, because this 2 is right here and it will be multiplying with this fraction, I do like to represent 2 as a fraction as well. I think it just kind of makes things a little more clear. Okay, so the next line, I am just going to combine that and rewrite it nicely. So what I have here is 1 raised, and actually I guess I could do this math too. 2 to the fifth power is 32. You can do that in your head, or you can use your calculator, or you can use your fingers, right? It's like 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, right? That's 5 fingers, okay. So 1 to the 32nd power multiplied by, no, I'm sorry, that's not 1 to the 32nd power. 1 divided by 32 multiplied by 1 over x to the 15th power. And so 2 times 1 is 2, so that's plus 2 over x raised to the third. All right, there's another level of combining we can do here. If we multiply this, 1 times 1 is 1, and 32 times x to the 15th is 32x raised to the 15th plus 2 raised to x to the third. Okay, so at this point, in essence, we're just adding 2 fractions, right? And if you're adding 2 fractions, what you need here is a common denominator. And so if you look at this x raised to the third power, it can actually just become this denominator. If I multiplied it by 13, if I multiplied it by 32, and if I also multiplied it by x raised to the 12th, because x raised to the 12th times x to the third would give me x raised to the 15th. So what I'm going to do here, I want you to really focus on this idea here. If I multiply this over here by 32x to the 12th, if these things multiplied, it would create that common denominator. But we just can't go around multiplying by stuff unless you only multiply by 1. So I can re-represent this like that. And essentially, if you really think about this, 32x raised to the 12th divided by 32x raised to the 12th is no different than saying 1. And if you multiply by 1, nothing actually happens. So what we're doing is we're just rewriting it to create a common denominator, but we're not changing the value. We're not changing the value at all. So if we did that multiplication, we just do some nice rewriting here. I have 1 over 32x to the 15th added to, okay, and if we do the denominator, x raised to the third times 32x to the 12th, well, that actually does give me 32x to the 15th. Now you can see I have a common denominator. And on top, and you could just do this math right here, but look right here. It wants the 2 to stay. This is the big clue. They say write it in this form. So it wants that 2 to stay. So I'm going to let that 2 stay. And I'm going to multiply that, because that's what happens in between here, by 32x raised to the 12th. Now, if you look right here, what we have, and look where they want us to go, they said they want a plus 1. Well, that's that right there. Because we're adding these, and they are a common denominator. Let me scooch down a little bit. Because they are a common denominator, and because addition is communicative, I can add that plus 1 anywhere I want. So I could write 1 plus all this over the denominator, or I can really try to mimic that form. So I'm going to try to mimic that form. So I'm going to say 2 multiplied by 32x to the 12th plus 1. And because it's a common denominator, I can just rewrite it all over the same denominator. Okay, now you can look. And you can see here, they're looking for the a here. That's 32. And the a up here is also 32. So you can see straight away that the answer is a is 32. And we did it. Good job. Let's keep on moving to question number 2. All right, question number 2. This is probably one of the more straightforward questions on your quiz. It's really just you showing me that you know how to distribute this exponent in, and then what do we do afterwards. So at the gate, this is going to go here and here. So if we rewrote this nicely, you'd say I got 3 to the 3rd power multiplied by y, and 4 times 3 is 12, to the 12th power, plus 2y to the 7th minus 4y to the 12th. Okay, good. Step 1. All right, well, what is 3 to the 3rd power? Well, 3 times 3 is 9. 9 times 3 is 27. So essentially, not essentially, we got 27 y to the 12th plus 2y to the 7th minus 4y to the 12th. Okay, and when we look at this, pluses and minuses are very restrictive, right? This is where we get into the big concept of like terms. You can only add and subtract like terms. So if you think of y to the 12ths, they're like apples. If I had 27 apples and I took away 4 apples, well, I would only have 23 apples. And that's the same thing with y to the 12ths. If I have 23 y to the 12ths and I take away 4 y to the 12ths, I would have left 23 y to the 12ths. And then I add to it plus 2y to the 7th. And that's it. You're actually done, because these are not like terms, so we cannot take them any further. And that's it. That question is done and dusted in the books. Good job. Let's go to question number 3. All right, here we go. Question number 3. So this is another rewriting of an expression and then solving for a given value. And so they want us to find a. And so they're telling us this can be rewritten as this. And this format right here should be a really, really big indicator that factoring has happened. And quick reminder, I'm going to do like a side example real quick. This is not the problem, but like a side example. Remember, factoring is like the opposite of distribution. So let's say if we had, let's say 2x to the 2nd plus, let's just say x. Yeah, there we go. If we had this, we know we have these 2 terms. Well, it can be factored. And you just ask yourself, well, what do these terms have in common? So this term has an x, and that term has an x, so I can factor out an x, or divide out an x. But you just can't divide it and get rid of it. You got to keep it somewhere so we know what happened. So essentially you're saying, well, I took out this x, and when I took it out, if you divided this x out, you'd be left with just a 2x, and then x divided by x is 1. And so this is the exact same expression, only this one has been factored. Okay? And if you looked at this, if I told you to distribute it, well, if you put it right back in, well, x times 2x would give you 2x squared, and x times 1 is x. You can see we're right back where we started. So this is the pattern of factoring and distributing, and factoring and distributing, and factoring and distributing. Okay? And it really does typically have a nice look. And you can see, well, okay, I'm going to be factoring something. So we're going to have that in the back of our head as we go through this. Okay, so let's work over here. Right here we have 2 raised to the x plus 3. So if we can reverse this back, we know that this is the same as saying base 2 raised to the x power multiplied by base 2 raised to the 3rd power plus 8. Nicely rewriting this is like saying 2 raised to the x power times 2 to the 3rd power is 8 plus 8. And just for the sake of explanation, I'm going to rewrite it like this, with that multiplication symbol just implied, okay? Because if we look at this, and I just give you that little talk on factoring, I have two terms, right? What do these two terms have in common? 8. Very good. So I can factor out that 8. So if that 8 factors out, it's going to look like this. The 8 factors out. So I'll have 2 raised to the x power, and 8 divided by 8 is 1. And you can see that this format here now looks just like that, right? And so our a value, boom, is 8. So a is 8. All thanks to factoring. Good job. Let's go to question number 4. All right, question number 4 really just hinges on having the knowledge of we understand what a natural logarithm is. And a natural logarithm, right? The natural logarithm is the same as saying log base e. That's it. So step 1, just rewrite this as log base e x equals 6. Okay? And to solve for this, we need to move into exponential form. And it's your lucky day, because if you look in your formula booklet right here, it just shows you the exact pattern of how to move from exponential to logarithm and logarithm to exponential. It's all right there. So long story short, log base e, that means in exponential form, my base is still e, okay, raised to the 6th power, and that will give me x. And for all intents and purposes, I'd be pretty happy with this as an answer. But if you want to give me a more exact answer, you can just look at your handy-dandy calculator, find e. Let's see, where's e? Is that it right there? Let's see. Second e, there we go, raised to the 6th power, right? Boom, 403.42. Okay, so you could also give me the answer that way as well. Let's do question 5. Good job. All right, moving on to question 5. Down, down, down we go. All right, wow. So it has this big number, and it says, I want you to write this number as an exponent with a base of 7. So if we had to kind of think about this, as an exponent with a base of 7, so it's saying 7 to some power, okay, I don't know, x, sure, is, and what is that? 1,977,326,743. Woof! Wowzers. Big number. So the key to this is understanding, well, I'm in exponential form, but when I have my variable up in the exponent, this is a great opportunity to shift into log form, okay? So if I have an exponent with a base of 7, I also know I have a logarithm with a base 7. Okay, that comes down. All right, and then I know that the logarithm of a base 7, it's eventually going to get to this number. Right, that's the argument. That would give me my x. So they're saying 7 raised to some power would give me this value, and this would tell me the value. So all I got to do here is really just, it's a calculator game, okay? Let's come on down. If we look at this, we got to figure out how to get to a log base 7. So the best way to do this is just hit math. Go down, 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 down. Log base. Right there. Doop. You can see it. Easy peasy. So I hit 7. Now I just got to carefully punch in that number and try not to make a mistake. 1,977,326,743. Ta-da! It's 11! Great! So there you go. X is 11, or 7 raised to the 11th power. And if you wanted to check that, right, just do 7 raised to the 11th power. You get the same value. And there you go. Good job. Let's do question 6. All right, here we go. Question 6. It says find the value of k if you got log base k 2,401 equals 4. Okay, so really just move it into exponential form and work it out. So check it out. My log base k means my exponent would have a base k. This goes here, and then use the argument 2,401. And remember, guys, if you struggle with that, it tells you right here in your formula booklet. SL 1.5 Exponents and Logarithms. Use the formula booklet. You're in business. All right. So now I got to get k all by itself, but it's being raised to the fourth power. So the opposite of being raised to the fourth power, the opposite operation, is we just take the fourth root. So essentially I take the fourth root of k to the fourth, it makes those cancel. It's going to give me the fourth root of 2,401. Okay. So that's going to give me k equals, let's see here. Again, this is a good opportunity to go to math. Number 5, unless you change the piece right up here so it can be a 4. Ta-da! And we just say 2,401. And it gives me a 7. K is 7. And you're done, just like that. Way to go. Good job. If you want to check it, you can just do 7 to the 4th power. And it should give you 2,401. There you go. Good job, team. Keeping it moving down the line. Solve for x. This is number 7. Solve for x. Again, this is really just a game of moving into exponential form. So I have log base 6, all of this equals 3, right? So if I want to move into exponential form, well, the base of my exponent is still 6. Raised to the 3rd power, and that's going to give me 2x over x plus 4. There you go, right? Well, let's see here. What is 6 to the 3rd power? 6 raised to the 3rd power is 216. So really I have 216 equals 2x over x plus 4. Okay, so I want to, first I kind of want to get rid of this fraction. I want to resolve that. So the opposite of dividing by x plus 4 is multiplying by x plus 4. So if I multiply both sides by x plus 4, that's going to cancel on this side. So I'm going to get 206. I guess I can just show you. Okay, let's do that. Let's do some good math. If I multiply both sides by x plus 4, how's that? Okay, these cancel. Okay, and then we distribute. So 216 times x is 216x. And 216 times 4 is 864. I'm going to double check that. I think that's right, but let's just see. 216 times 4. Yeah, 864. Good. Okay, and that's going to equal 2x. There you go. So now we've got to solve for x. So I got these like terms. So I'm going to subtract 216 from both sides. Okay, that's going to go away. So I'll get 864 equals, well, 2x minus 216x would be negative 214x. There we go. We'll come on down a little bit. And now I just divide both sides by negative 214. Right? If I divide both sides by negative 214, I'm going to get x is, and let's find out, 864 divided by 214. Oops. 864 divided by negative 214. Ba-dum-bum. Negative 4 point, so we have 0, 3. The IB always says 3 significant figures, so that 3 rounds up to a 4. And there you go. That is question 7 in the books. All right. Next up, I want to go over the next page, which is all those communication concepts that I hope you guys all are prepared to discuss. Let's do that now. All right, here we go. This is the communication portion. The first idea that you want to have locked in your head is moving from log form into exponential form. This actually probably won't ever be a specific question per se for the communication topics because it is given to you, right? Like this is it. That's all you would have to write. So that's right there in your IB formula booklet. So I'm not going to spend much time going over that. Moving from exponential form into log form, same idea. These ones are all given in your formula booklet. So check, check. You guys got those on lock. Okay, interesting question here. It says, what is the base of log, right? So this is kind of working on understanding that if you're given just log, do you understand what the implied base is? And the idea is that when it just says log, it's because the base is 10. Okay, so that's what we should know. If it just says log, then you know the base is 10. Okay, natural logarithm, this is the same idea. Although if you get ln, do you understand that the base is just log base e? Okay, there you go. This one, writing natural logs in exponential form. So that's like saying if you get L and x equals y, could you move that into exponential form, right? And that's like saying, well, I know log base ex is y. That's just understand that this is that. And then we would just say, well, exponential form is my base is e, my exponent is y, and it gives me x. So understanding that idea right there. Okay? All right. And here we go, the last part. This is all from your notes. You guys can find this in your notes and lots of other places. But let's just talk about it. The reciprocal law, this is like saying base a to the negative m power is the same as saying 1 over a to the m power. That right there is the reciprocal law, okay? The product law, it's like saying base m to the m power times base a to the m power is the same as saying base a to the m plus n power. Okay, and you should be able to go from left to right, right to left. Same here, left to right, right to left. Okay, no big deal. Quotient law. This is like saying if you know that you have a base a to the m power divided by base a to the n power, that is the same as saying a to the m minus n power. And same idea. Can you go from here to there, there to here? Make those connections. And then the last bit here, when we look at these, this can go a couple directions. So let's just we'll just run them out. This is understanding that if you have, for instance, a raised to the m power, and all that goes to the m power, that you know that this is just like saying a to the m times n. That's one way we could express that idea. Let's come down a little bit here. In the same vein, if you had something like this, like a times b raised to the m power, understanding that that's the same as saying a raised to the m and b raised to the m, and we do that all the time. That's because we separate those. That's like a times b, so the m distributes to both. And the last one, which we haven't seen as much, but you guys are pretty good with this. If you have a divided by b raised to the m power, understanding that m goes to the numerator and the denominator, and it will look something like that. There you go. Those are the different ways the power law kind of expresses itself when it comes to exponents. Okay, so there you go. This is everything you guys need to be successful. I hope it helped. And as always, you got any questions, let me know. Thank you. Bye.